Okay, for example 2, we have xy cubed over x to the 1/2 to the 2/3 power. So we got several things going on here. Let me show you a couple rules that can be applied here. First rule I'm looking at is, they call it a to the b. That rule there, which is on your note sheet, the power of power rule. Some power structure raised to another power, you're going to take the same base and multiply the powers together. We have the power of product rule. Which is that. You can actually combine those rules together. It's not on your note sheet, but you can combine those rules together. If there's some power in here, let's say there's a C and a D power maybe, then this would be A to the CM and B to the DM. All right, that's legal also. All right, and the other rule that's happening is that the quotient of powers rule. Okay. Just to highlight where those rules are happening, just to show you here. This rule here, I've got x on top, I've got x on bottom. This rule here is just obvious the whole thing, right? So you got the parentheses to a power, that's where that rule's happening. And finally, this rule here is more what's happening. We got this whole object to that power. So there's where it all happens. It's up to you to determine what order you do things in. I like to do this rule first before I deal with these other rules. That's me. So if I'm looking at this problem and the current structure inside this parentheses is an x and a y on top and x on the bottom, I'm going to rewrite that structure. So x and a y on top and an x on the bottom. And the rule here, this green highlighted rule, says if things are powers inside, I can take the inside power times the outside power. So the inside powers are 1 and 3 and 1/2. The outside power is 2/3. So for x, for this x on top, I've got to do 1 times 2/3. What does that equal? 2/3. For this y right here, comes from here, I got to do 3 times 2/3. What does that equal? Very good. 3 times 2/3, 3's cancel, so we're going to get 3 times 2/3 is going to equal 2. And then this x on the bottom, which is here, we have to take 1/2 times 2/3. What does that equal?
1/3.
1/3. Very good. The 2's cancel, so we're going to get 1/3, right? Don't want to need the parentheses anymore when we do that. So we have 3 objects inside the parentheses, x, y, and x. Their powers inside 1 and 3 and 1/2 get multiplied by the outside power 2/3. We evaluate those. Feel free to go somewhere else to evaluate them, or if you can do it mentally, that's fine also. 1 times 2/3 is 2/3. 3 times 2/3 is 2. 1/2 times 2/3 is 1/3. And once we've accounted for that rule, which is kind of a combination of this green and yellow highlights, now we're going to do this division rule. It says if you have the same letter on top and bottom being divided, you're going to subtract the powers, top minus bottom power. Now I've given you a variation of that rule previously. If you just notice subtract the powers, always put the answer where the bigger power is. In this case, the bigger power is on top, right? So the rule is as it is. So I know I'm going to get x on top, I'm going to get y squared on top, all right? I haven't got the power of x yet, but x is going to be on top because 2/3 is bigger than 1/3. There's nothing happening to y, so it stays y squared, all right? And the rule says I'm supposed to subtract the powers. So to take the top power 2/3, subtract the bottom power 1/3, what does that equal?
1/3.
1/3. Common denominator is already there. And that's the simplest form of the answer that you can get, x to the 1/3 y squared. When you get variable answers like that, feel free to leave fractional powers in your final answer. Unless they ask for a radical answer, They don't ask for that, so if they ask for a radical answer, you gotta go back to radical form, but they don't here, so I'm fine with the fractional power and finite.